Can you hear me? Let me see if I can amp this up a bit. How about now?
Yeah.
Yeah, is that better? Okay. What I'd like to do in the 5 minutes I've got here, it's a tall order, but to offer sort of a broad sweep of what some of the major climate change issues are, and looking at from a global perspective and the context of U.S. agriculture in a global world where food production will become more volatile and will decline in some areas and increase in others. According to the Intergovernmental Panel on Climate Change Fourth Assessment Report, climate change is unequivocal. It is happening. There's warming in the climate system. Much of it can be attributed, not all of it, but much of it to greenhouse gas emissions from human sources. Temperatures have risen about 0.7 of a degree across the globe over the last century. Much of that has occurred in the last few decades. We're on track over the next couple decades for about 0.2 degree rise per decade. After that, it's anyone's guess. James Hansen from NASA and others have said the dangerous threshold for climate change is 2 degrees centigrade. We're very likely to overshoot that, given that we would need to cap our CO2 emissions by cap them by 2015 and begin to reduce them, stabilize them way below 1990 levels by the middle of the century. So what we're looking at is an overshoot of that dangerous level. And there's there's vast unknowns in terms of the nonlinearities in the climate system and the potential for positive feedbacks such as dieback of forests that will accelerate and amplify warming. In terms of temperature, what will a warmer world look like? There was an interesting study in Science that came out about a month ago that suggested that by the end of the century, average summer temperatures will exceed the most extreme heat waves we've seen over the last 10 years. So imagine the 2003 heat wave in Europe and the devastation that caused. Imagine that as an average summer temperature. And this will have a significant impact much before that in the tropics and subtropics. Cereal production is expected to decline with only about 1 degree centigrade rise above 1990 levels, and that's expected to occur by 2030. So, for example, maize production in Southern Africa, wheat production in South Asia. And as we move further through climate change, then other systems are going to be vulnerable. On the other hand, there's going to be a redistribution of agriculture poleward, and agriculture in high latitude regions is expected to benefit from warmer temperatures. And because of the increased energy in the system, the hydrologic cycle will become more accelerated, and this is likely to increase climate variability. Warmer air holds more moisture, so we're expected to see fewer but more intense storms, longer periods between rains, and warmer temperatures. In fact, that's already being observed, and that's going to have a significant impact on rain-fed agriculture, particularly in sub-Saharan Africa, South Asia, and elsewhere. And there's going to be an increase in severity and frequency of extreme events. So droughts are expected to become worse, the return period for floods faster, and heat waves more intense. That's the likely impact over the next few decades, is that of increased variability and increased toll of extreme events. And looking more long term, there's expected to be drying across much of the subtropics. So for example, Southern Africa, parts of Mesoamerica, West Asia, Mediterranean basin, the intercontinental United States as well. It's projected to get drier. But there's many uncertainties as well related to rainfall in the tropics. And as a result of that, there'll be, how am I doing on time?
Sorry, I'm 1 minute.
Many winners and losers in agriculture. The losers, as Howard pointed out, will be in the global south, where there's already 850 million malnourished people and expected to be a population increase of 3 billion by the middle of the century. And in these areas, the suitable land for agriculture is expected to decline. The area available for double cropping will decrease, and other impacts. In terms of the key indicators I was looking at, there's a number of them. Briefly, one of the key issues is obviously agricultural water use. And Mark will speak to that. Sorry.
It's okay.
Yeah, we'll speak to that later. And in that sense, areas that are already over-allocated for water could face severe stress. So for example, reduced snowpack, earlier spring discharge of water, shifts in seasonal water availability, increased competition between agricultural and non-agricultural uses of water. And with increased storms, there's also going to be issues of soil management. More intense storms will produce more runoff, increased soil erosion, more crop damage. And then one of the effects that's not very well understood is that of pests and diseases. That there's likely to be, with warmer temperatures and changes in precipitation, shifts where there's going to be more intense pest damage and new pest complexes emerging, both from increased CO2 as well as changes in climatic conditions. And this is also going to occur against a backdrop of potentially reduced options for pest management as high temperatures will deactivate resistance genes and some of these other factors that we use to manage pests now. And lastly, temperature rise will obviously produce a number of impacts, both positive and negative. In terms of the availability of data,
3 seconds.
Okay. Sorry. We have a number of global climate models. There's lots of uncertainty in them, and there's a lot that needs to be done to improve the communication between climate scientists and other scientists, better understand sources of uncertainty and learn how to work with them better. Thanks.